Hi everyone. Today we're going to study sum of finite arithmetic series. Let us define arithmetic series. If a sub 1, a sub 2, a sub 3 up to the last term a sub n is a finite arithmetic sequence, then a sub 1 plus a sub 2 plus a sub 3 plus all the terms up to the last term a sub n is called an arithmetic series and denoted by S sub n. This is the general form of arithmetic series. Let's have examples. Here we have S sub 2 equals a sub 1 plus a sub 2. It means we are going to take the sum of the first two terms. Second example, S sub 5. It means we are going to take the sum of the first 5 terms of the arithmetic sequence. So you see, this is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. Example 3 is S sub 10. So let us take the sum of the first 10 terms of the arithmetic sequence. So here we have a sub 1 plus a sub 2 plus a sub 3 up to a sub 10. Let's go now to the sum formulas for finite arithmetic series. We have the first formula, and it's written as S sub n equals the fraction n over 2 times the quantity 2 times a sub 1 plus this binomial n minus 1 and multiplied to d. We are going to use this formula if the given are the first term, that is a sub 1, the common difference, that is d, and the number of terms, and that is n. We will use here and also here. There is also the subscript of the s. There is a second formula, and it is S sub n equals the fraction n over 2 multiplied by the sum of a sub 1 and a sub n. We're going to use this formula if the given are the first term, that is a sub 1, the last term, the a sub n, and the number of terms, and that is the n that is used as numerator on the fraction and the subscript of the s. Let us have example 1. Find the sum of the first 20 terms of the arithmetic sequence 2, 7, 12, 17, so on and so forth. Let us list the required and given data. S sub 20 is the symbol for the sum of the first 20 terms. A sub 1, the first term, is equal to 2. The common difference is not directly given in the problem, but we can compute by simply subtracting 2 consecutive terms, like this: 7 minus 2 is 5, or 12 minus 7, that is also 5, or 17 minus 12 is also 5. And n equals 20 as specified in the problem as first 20 terms. Let us use the first formula. S sub n equals the fraction n over 2 times 2a sub 1 plus the quantity n minus 1 times d. Let us substitute the values respectively. The n is now 20. The a sub 1, the first term, is now 2. The n here is also 20. And the common difference is 5. Simplifying further, we can have this 20 over 2 is 10. 2 times 2 is 4. 20 minus 1 is 19 times 5. And then we will multiply 19 and 5. It becomes 95. We will take the sum of 4 and 95. We will get 99. Still, the number 10 is copied down here, and the s sub 20 is here. So 10 times 99 is 990. It means the sum of the first 20 terms of the given arithmetic sequence is 990. This is our final answer. Let us have example 2. Find the sum of all the odd numbers between 51 and 99 inclusive. Let us list the required and given data. The first is s sub n. This is the sum of all the odd numbers as required in the problem. The first term is 51. The a sub n, this is the last term, equals 99. The n, the number of terms, is not specified in the problem. So still this is a question mark. We can use the second formula because in here the given is the first term and the last term. However, we don't have the n. First, let us solve for this n. Remember, we have the general term formula that is like this. A sub n equals a sub 1 plus the quantity n minus 1 multiplied to d. Let us substitute the values. The 99 is the last term, so we will put here equals a sub 1 is the first term, that is 51, plus the quantity n minus 1 will be same, and d is 2. Remember, the interval between odd numbers is 2. So that is the common difference. Let us simplify this equation, then solve for n. So on the next line, we will multiply this number 2 to n and to negative 1. So we have 2 times n is 2n. 2 times negative 1 is negative 2. And then this 51 and the negative 2 can be combined together as 49. So we just copy this positive 2n and the 99 on the left side. Let us isolate the 2n. This 49 must be transposed on the left side. So from positive, it becomes negative. So 99 minus 49 equals 2n. So the difference is 50, and this is equal to 2n. Let us simplify by dividing this equation by the coefficient of n, which is 2. So this 50 divided by 2 is 25. 2n divided by 2 is n. So we can write n equals 25. This is the number of terms, and this value we will copy opposite the n on this side. Now, we can now solve for our s sub n. By the way, this n here as 25, we can now change the s with the subscript 25. Also, the a sub n becomes a sub 25, and this 99 is the 25th term of the sequence. Let's go now to solve for s sub 25. Substituting the corresponding values, the n is now 25, a sub 1 is 51, the a sub n or the a sub 25 is 99. Then let us simplify further. This 51 plus 99 is 150. And then let us cancel this 150 and the denominator 2. We will get 75 multiplied to 25. And the product is 1875. This is our S sub 25. This is our final answer. Let us have example 3. Find the a sub n, a sub 10, and s sub 10 of the arithmetic sequence 3, 7, 11, 15, so on and so forth. Let us list the required and given data. The first is a sub n. This is the general nth term. Next is a sub 10. It means the 10th term. Next, s sub 10. This is the sum of the first 10 terms. Given is a sub 1. That is the first term, which is 3. And the d, which is equal to 4. Although it is not readily given in the problem. But we can compute by subtracting two consecutive terms, like 7 minus 3 is 4, or 11 minus 7 is also 4. 15 minus 11 is also 4. So let us start by solving a sub n. Let us substitute the first term and the d, the common difference. So we have a sub n equals 3, the first term, plus the quantity n minus 1 will be same, multiplied to d, which is 4. Let us simplify further. This number 4 will be distributed to n and to negative 1. So 4 times n is 4n. 4 times negative 1 is negative 4. Then let us combine this positive 3 and negative 4. So we have negative 1. So our a sub n equals 4n minus 1. So this is the value of a sub n as a function of n. Let us copy this value opposite a sub n in here. And then let us clear the board and solve for a sub 10, the 10th term. Let us use our general term formula. So that is a sub 10 equals a sub 1, the first term is 3, plus n is 10 minus 1, multiplied to d, which is 4, the common difference. Simplifying further, this 10 minus 1 gives 9, and let us multiply 9 by 4 is 36. Then the sum of 3 and 36 is 39. This is our a sub 10, the 10th term. Let us copy this value opposite a sub 10 in here. Then let us clear the board and solve now for S sub 10, the sum of the first 10 terms. Let us use the second formula, a simpler one, because we have the first term and the last term as defined. We can also use the first formula here. However, the second formula is much easier to use. So S sub 10 equals n over 2 is now 10 over 2 multiplied by a sub 1, the first term is now 3, plus a sub n, or this is a sub 10 equals 39. Simplifying further, 3 plus 39 is 42, and then 10 over 2 is 5. Let us multiply 5 times 42. The answer is 210. This is the sum of the first 10 terms of this arithmetic sequence. Let us copy this value opposite S sub 10 on this side. So we are done with our example 3. These are the final answers. I hope you learned something from this video. See you again next time.